In a minute, we will start our session, our meetup.
Okay, so I am recording, and you now have the total ball for admitting people in the waiting room. Okay.
Okay. Hello, everyone, and I would like to welcome Johanna Rothman, who joined back in 1980 as software engineer, even before I was born. To say about her experience, different roles, starting from software to systems engineer, program manager, quality manager, and now she is author of 18 books, or even more soon, and a speaker and a consultant. Mostly her focus, as I understood, is a special interest in life cycles and continuous integration and agility of management in particular. And I think she can say more, add something more about her now.
So I don't think I need to add any more, but I will say if you have questions, please put them in the chat, because I am expecting to talk for, maybe 20 minutes unless I get going. And if you have specific questions as I proceed, add them, and then we will have plenty of time to discuss how different practices like continuous integration, especially inside the project, can help you get feedback even if you cannot ship outside the doors. So let me start. So let me talk a little bit about life cycles. It turns out that Winston Royce wrote his 1970 paper about how life cycles might work back in the days of the IBM 7090. Now look at that computer on the screen. There's a person with in front of a large console. There's tapes, right? Look at all those tapes and all those boxes in the back. That was memory, probably hand soldered memory. So we are talking about a time when people had to use literally key punch people. When my first job out of school, I had I graduated from college in 1977 with a BS in computer science. When I was at school, we actually mostly used the time sharing operating system for the Xerox Sigma 6. Now, I know none of you actually know anything about this computer. It was great. I used Fortran, I used assembly language, I learned all kinds of different languages. And my first job out of school, I was working on a hardened IBM 360 that was going to go into the field as a telecommunications product. That was a phone system for the Department of Defense. We had key punch ladies. So we would handwrite our code on literally kind of 14-inch paper, and the key punch ladies would give us back our cards at the next day. We then desk checked our cards. Now, before this, we had designed, we had and gotten design review. We had written pseudocode to make sure that we were doing okay with our logic. We had gotten review on that code. Then we had our real code, and then we could have about a minute once a day to make sure that our code worked. There was nothing continuous about that integration, right? Nothing at all. So think about the context where Winston Royce wrote his paper. Now, the very first picture in his paper is a waterfall. And he actually said something like, it would be really nice if we could do this. But that's not how software works. It works the way with feedback. And what I did in my first job out of school, I had feedback on the architecture. I had feedback on the design. I had feedback on the code. I had all kinds of feedback loops before I even got to the key punch ladies. So Royce actually said to iterate. And the problem with with a waterfall life cycle, whether it's a V model or something else, is that it looks as if you could predict what was going on. And it's so hard because software is all about learning. We learn as we proceed, right? So I was able to take the feedback from my design review, from my pseudocode review, from all the reviews, and use it to inform the next bit of work. So that's kind of the history and the context of life cycles. Now, think about those 7090 computers or even the IBM 360, and then think about what's on your wrist, or maybe what's in your what's on your phone, right? Your phone has way more capability than any of the computers we use in the 70s, the 80s, and even the 90s. Even a lot of the O's, right? So think about what's on your wrist. I wear my Apple Watch all the time. I'm not sure what I would do without it, and I use barely any of that. So think about the capabilities and the context we have now for what we used to have then. I am not willing to go back to the bad old days, even if some of those bad old days were actually quite fun, but I want to continue going forward. So since our tools have changed and our computers have changed, our approaches also need to change. So this particular table talks about the risks on the top and the kinds of other risks on the side. So if you have a high cost risk, you might want something in the leftmost column where you can think about where your other risks are. Now, the cost is the cost to release. What about the technical risk? Do you actually know if you can make this product? That's the high technical risk. So you might not even know if you can make this product, in which case you probably want to use some kind of iterative or incremental or agile approach. And what if you have a high release risk that the date to release or the actual release itself is a risk to your project? Then you want to really think about the other kinds of life cycles. And a high defect risk means you need a lot more iteration through the project. So you get feedback all the time. So only a high cost risk you might be able to manage with in a very short time. You might be able to use a serial life cycle. But my experience with a serial life cycle is that the longer the duration is for the project, the more risky that particular life cycle is. I bet you've seen this. Caper Stones actually has data and details about why the longer the project, the higher the risk if you use a serial life cycle. He says it's because the requirements tend to start changing in about the 4-month time frame, and they change substantially by the 6-month time frame, and by the 8 or 10-month time frame, they've totally changed. So if you can do a 3-month project, you can use any life cycle you want. But if you have other kinds of risks, it's time to consider how you want to add or change your life cycle. So the original waterfall was one delivery for all of the feedback. I don't even have deliver at the end of this because that we assumed that after test we could deliver. And notice that the original waterfall tried to manage cost because back in the old days, we did a bunch of re-estimating, replanning, and possibly canceling at the end of every phase. So that allowed us to manage the costs for our project. Now, this is my V model. One of the things I really like about this is that there is feedback inside the project, right? So there's feedback from module design to unit test, right? Do you need to change the design if you do the unit test and they tell you something? Same thing for all the way up. Now, what I do find is notice that you could get to acceptance tests realize that you have a requirements problem, which is actually very common, and have to do the entire model again. So you have a very long feedback loop, very, very long. And this also optimizes for one delivery. Now, if you optimize for coding, think about what happens in the project. I find that coding, back when I was a software developer, and I freely admit I have not been a software developer for many, many years, coding was the least of my activities. I spent a lot of time thinking. I spent a lot of time reading what other people had done. I spent a lot of time trying out designs, either on paper or maybe with prototypes. So I spent a lot of time on the left-hand side of the V model. And once I got to the right-hand side, if I had spent enough time, I still had to go back. So coding is kind of the least of our issues. But thinking, rereading, understanding, talking to people, learning together, those are where we have issues in our projects. So what's really interesting is that though there's a whole big misconception in the waterfall that we think we can manage the money because we finish the work, but we don't actually know whether or not the work is finished, because knowledge work is all about learning as we proceed. So remember, this is what accountants think a serial life cycle is. This is the reality, and there are several realities. So I find that a lot of my clients, before they move to an agile approach, say, we're just going to keep revisiting the requirements until we get most of the way through code. And then if they say, we're going to try and limit our test time, which almost never works. The requirements actually go through integration. And then this is, I find that what more happens is alternative 3, that we do some requirements, then we go to analysis. Maybe we don't have a feedback loop from analysis to requirements, but certainly by design we do. And then by the time we get to coding, we realize we have more different requirements. And then when we get to integration, more and different requirements. More when we get to test, more and different requirements. So there are many, many more feedback loops here. But this is the problem with the serial life cycle. So we need feedback more often. And the problem is a one delivery approach does not give us feedback inside the organization, and it definitely does not give us feedback outside the organization. So let me talk about the first kinds of iterative approach. Barry Beam, I think that's how he says his name, came up with a spiral life cycle. He had this really nice picture of a spiral, but it makes me confused every time I look at it. So I actually drew it out more as a project manager would draw this out. The nice thing about the spiral life cycle is notice that we try and get requirements, and then we create a prototype. Notice it says check with customer. Now in the original spiral, we were not shipping to a customer. We would show the customer, talk to the customer, right? And then there was this replan based on feedback. We might have replanning back to the requirements. We might have replanning to go forward to the next prototype. And we did that again and again and again, as long as we needed to. Now, I happen to make most of the boxes here a similar size. That's not necessarily what they were like. The boxes could be any duration, right? This is not time boxing. This is scope boxing to get feedback on prototypes. Now, the interesting thing about finishing the prototypes is you might not have integrated all the prototypes as you went. So in fact, in the original spiral, they did not integrate the prototypes as they went. They had standalone prototypes. They had to merge them all together. I think that we are unlikely to do that. They still had only one delivery at the end. So this is better feedback, especially if you talk to customers. But the integration, notice that there's no continuous integration, there's no stage integration, there's just integration as a blob on the end. I shouldn't say it a blob, but it felt like that. That's where death marches came from. So then the iterative approach turned into evolutionary prototyping. So notice that there's a lot more feedback. And if you don't actually take the feedback, then you have what I call the kiss of death. That if you only refine feedback at the very end of all the prototyping, you're in a death march, because then you realize, oh, our requirements are not good. So, and we still might have integration all at the end. It all depended on how people used evolutionary prototyping. Most people by the middle of the O's were using prototyping with integration, but then you ran into the problem of the prototype was actually what you put into the code base, as opposed to fixing the prototype for final code. So it's a problem, and there's still only one delivery. Now, the interesting thing is that some of us use the incremental approaches. I use design to schedule at once. That's where we said, what are the requirements? What's the analysis to choose the overall architecture? And then we worked on the highest priority features, right? So feature A, high priority, then feature B, medium priority, then feature C, feature D, feature E, all like that. And notice that we used design, code, integrate, and test. So you could release at the end of every high priority feature. That's the value of an incremental life cycle. And notice all the feedback loops. Then assuming you take feedback loops, you might have a variety of feedback loops in blue. However, if you get to the lowest priority feature and you design, code, integrate, and test it, and then you realize that changes your requirements, and you decide you need to have that lowest priority feature, you could be in trouble. So that's where you have to go all the way back to requirements. But notice you could release, assuming that you have done all the design, code, integrate, and test, that you have put this thing together, that assuming the cost to release is low enough, you could release after every priority feature or feature set. So that's where you expect to have several releases. And since you're in the automotive industry, I'm going to talk about hardware in a minute. Well, several minutes. Now, stage delivery says, okay, we can do that one better. We don't have to actually worry about the highest priority. We can mix and match the various features or feature sets. We might do high priority feature 1 and not do the rest of feature 1 feature set, and do high priority feature 2 and then do the rest of feature set 1, then do the rest of feature set 2. If you have ever worked on a product where you say, oh, we have 30 features in this feature set, but only the first 2 we really, really need right now, that's what stage delivery is perfect for. So again, because you're design, coding, integrating, and testing as you go, you can release as you proceed, assuming the cost to release is not that high. And then you might have a final integration and a final test. I find in my experience, those were very short because we had been integrating as we go. We did not have prototype features, we had finished features, so we could add on the next features and feature sets to the original features that we had. Now, I use this combination life cycle that does not have a name. I used to call it my favorite JR life cycle because before I discovered agility, this is what I knew. So We got the initial pass it requirements, and I am kind of a pain in the tush because I used to say to the marketing people, well, I should say the product management people, look, you get 2 weeks. At the end of 2 weeks, you're going to give me what you know for requirements. I'm not staying in requirements hell. I'm just not doing that. No, 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 no. And then we created a bunch of prototypes. We prototyped for various feature sets. We prototyped for speed. We prototyped for reliability. Then, and I often time box that. So if I had only one team, we chose what to prototype and we got some feedback. Maybe within the team, if it was for a program, all the feature teams would prototype. We would discuss. No, some of those discussions were quite loud, and then we selected an architecture and high-level design. Then we fully implemented 3 features integrating as we go. That full implementation allowed us to test the architecture and demo what we already had. Then if we were okay, then we continued to proceed. If we were not okay, we went back we figured out what we needed to do from the prototyping stage because we had release criteria and architecture criteria, and then we implemented more features. So there's more iteration here. This is not an agile approach. However, it gives you a whole lot of iteration on prototypes, increments on features, iteration on the big picture, and incrementation on finishing stuff. And we might have had final tests because we were integrating as we go. Continuous integration. Final test was quite short. So this life cycle does not have a name. It's fine. You don't need to have a name. If you want to use it and call it the Johanna Rothman life cycle, be my guest. You would be better to call it your life cycle, right? Call it your company life cycle. Now, let me talk a little bit about agile approaches. First, agile approaches only work when the cost to release is low. If you have a high cost to release, an agile approach is not going to work. I'm going to talk about that more with hardware. So there's iteration-based agile, which you understand if you've ever looked at Scrum, that's an example of iteration-based agile, where you get the requirements, you do the analysis, design, build, test, release, and deploy all in one time box. That deploy is really important. So, and every time box is the same duration, and you're always integrating as you go. Always, always, always. Most of the people I know who use iteration-based agile are not quite there yet, which is why I have a job. Fine. There's also a flow-based approach to agile. That's where we can say, for a given feature, let's clarify the requirements, and then we will do what we need to do. We are not working in time boxes, so we have variability in how long things take. There are WIP limits. If you're accustomed to using a Kanban board, you understand about flow. So you would understand how you work now, create WIP limits where that makes sense for you, and then continually improve your work. I happen to use much more flow-based approaches to agility now than ever before. I find that there are way too many interruptions for people, that the organization has not limited its WIP, work in progress. So we need to limit the WIP in the team so that the team can succeed. Now, this is the thing I was talking about hardware. If you look at the left-hand side of this, you can say, this looks a lot like Johanna's combo life cycle. And that's where we can do a whole lot of iteration. We can show ourselves what we need to know. We can do all this stuff. And then notice that if we have to show and test with software, and then if we have to add more features, we increase our schedule risk. Is this a problem? Not necessarily, but we need to know about it. Then once we have to go to physical form, that's when we have many higher costs to iterate once we go to physical form. So I have done evolutionary prototyping work for hardware. I've done a little bit of literally Scrum-based agile approaches for hardware for analog design. However, because the analog designers were always trying to manage the footprint and the heat dissipation and the reliability, there's all this stuff that's the extent of my domain expertise for hardware design. Okay, that's it. But I find that they were able to iterate over features very, very well. And once they went to physical form, they had the same problem that these folks had. So agility can work. It's all about the high cost to iterate, which is why I'm not once you go to physical form, which is why I'm not recommending that everybody use an agile approach for hardware. I just don't see it. I think the risks are way too high. So I like to think about the potential for release frequency. And that's if I can think about feedback about the product in terms of our releasing, then we can think about releasing outside the company and releasing inside the company. So the potential for release frequency is all about outside the company. Because the more you are with hardware or mechanical components, the less frequently you want to release because the cost to release is so high. The more you can do digital only products, and maybe some of you can actually there's firmware pieces which might be digital only that you can update from outside the product, then you can really use continuous deployment. But this business of even firmware, you have a cost to release. So I would like you to think about continuous integration as inside the organization, inside so you get feedback. And the more you continuously integrate so you can get feedback about the product inside the organization, the better you can make the product, even if you cannot release outside the organization all that frequently. So that's the end of my prepared remarks. I have a little book stop for Manage It. If you're doing programs, I talk more about life cycles in the program management book. So I'm going to stop the share and ask for questions. Okay, question away, people. If you want to turn on your video and come off mute, that would be great.
Johanna, I would ask my first question. So back in my career, when I learned about the Agile, it was I believe in 2006 or 5. I got this book from Ken Beck, Extreme Programming Explained. And at that time, I was doing software engineering, and it was like a breakthrough for me. So I can do some stuff faster and more synchronized than I did before when I use this extreme programming practices. So looking nowadays, when the product is even more complex and includes also hardware and cybersecurity, functional safety, and I don't speak about the basic ISO 9001 and ASPICE. So a lot of stuff bumping to the product, and we still need to meet time to market. We still need to meet quality criteria. So my question is, from your wide expertise, what is the turning point to whether to switch on using agile practices or not? can it help in this complex automotive industry, or not? Or we still should follow the model as soon as it works?
So let's talk about XP practices as separate from the life cycle. So a lot of XP practices are totally worth it for any project at all. So thinking about pairing so that you get eyes on the code, as well as continuous review, thinking about continuous integration, thinking about how do I use test-driven development? Because TDD is actually about design. It's not actually about testing, right? So when you start with tests first, you change how you think about design. I was never smart enough to do TDD. Yeah, never. We knew about it from clean room, but we didn't know. I didn't use it. I thought, oh, TD testing before, that's just silly. Yeah, shows me how smart I am. What's different about especially the automotive industry is that because you have so much hardware, and because the software tends to be tied to hardware, then it's very difficult to have frequent releases outside the building. Frequent releases inside the building, totally totally fine, right? So I think that especially when you have hardware, you have to say, is this going outside for feedback or staying inside for feedback? Those are the very big questions. And you can use XP, and I highly recommend all the XP practices as part of your development. And certainly you can use an agile approach. You can use slow, or you can use iterations. It doesn't matter. It's that once you go to physical form, that changes everything. The more price, I should say, the more cost and schedule pressure you have, the more you need to use an incremental or agile approach. You have to finish feature sets and see where you are. The more anybody waits for integration at the end, the less you know about where you are in your project. So you are more likely to take more time and to have it cost more.
Yeah, one more question. Back in your career, you used to work with robots. So it was the first company which applied robot image recognition in industry. It was Automatics, I believe.
Yeah.
So there, how your approach was towards combining both embedded hardware and software?
So, okay, so we had a special purpose language called, I believe, Rails, which is not the same Rail that we're talking about now as a modern computing language. It had sort of objects. We could pass messages to things that we called objects. It was not exactly object oriented. And what I did with my colleagues is let me see, I'm going to share the screen again so I can show you what I did in my, whoops. Okay, I'm not sharing the screen. Let me find my.
By the way, meanwhile, if anyone has questions, you can prepare them in the chat or just jump into discussion.
Yeah. Okay. There. I'll just leave it like this. You can see the sauce being made. So I did a combo life cycle for all the work I ever did at Automatics. And later on, when I worked at other machine vision companies, I also did this. I said, we are not going to know all the requirements at the beginning. So we did an initial passive requirements, because what happened is the salespeople would talk to the account people at This was at GM. So the salespeople and GM talked to each other. They came up with a contract. Us software people we did not always see all the details of the contract. We only knew the deadline for us to do this. So I used to do a lot of prototyping and figuring out what was going on. Did I actually understand the requirements? And by this time, I had an engineer at GM. So I was the engineer at Automatics. I had the engineer at GM. I could talk to the engineer and get feedback about what I did. So that actually worked out really well. And then I did not release features. So I fully implemented these 3 features as I went. And of course, I used continuous integration because what else would I do? It never occurred to me not to. That this is back when we had much smaller solutions, right? The kinds of things I did then are not the same kinds of things anybody does now. Let me make that totally clear. So I got feedback from him. Um, I had to go out to Detroit a couple times as I was implementing, and then show them in the setup on the factory floor. Right, we had a camera set up, we had the robot arm set up. So this was, as I said to Jeannie before we started, this is inspecting the glue on the windshield. So you could put the windshield into the car and know that the glue was literally all over and that it would make a good seal when you put it into the car. So I did a couple of dry runs, and then I would go out there and then I demoed what we had, and then I always learned something because, yeah, real life is never quite the same as what's in the lab. At one point, I asked them, is this the lighting? Is this all the lighting I'm going to get as on the factory floor? And that's when they said, oh, no, we're not going to let you on the factory floor. This is our lab. We have much better lighting on the factory floor. And I said, okay, I need to see it. This is back when we had cameras of, 8 bits of grayscale. I think about what we did, and I'm kind of astonished it ever worked at all. So, but I did a lot of iteration and a lot of showing to the customer before I actually delivered the final product. I did this with gauge inspection also. That did not have a robot. That was still that was just a machine vision application. But gauges, how do you know that the gauge actually works, right? You put it you do some kind of a simulation. Well, you're not going to have a person inspect the gauges. You need a computer to do that. So I use the combo lifecycle a lot, a lot, a lot, a lot. I also use stage delivery for some of it, but I needed more feedback. I couldn't wait until final integration. I needed to demo a lot more often there.
Johanna.
Yeah.
Peter from Switzerland, I have a question, and I've been in automotive and medical device development, and in my personal experience, I found that even hardware changes are sometimes much faster than software changes, because given a certain complexity, software changes are long lasting as well. We had a blood test sample and we needed to have another shaker, and that was done in 2 weeks, and the software took like 2 months to change. Well, anyway, and now you talked about the cost of deployment, and I think that in all these life cycles discussions, it's never really differentiated between developing a thing with hardware and mass production a thing, and that is totally different, I think. And I could think of, this is the question for me, that you say once something is deployed in a mass production, then it's like using a hardware as a platform and using the software to use it differently, like a better switch and gearing shifts with software, something like that. And Do you have any thoughts about that, that we should differentiate between development for mass produced things which are already out there or just for development?
That's a really insightful comment, Peter, because once you get hardware solidified, there is a cost to manufacture it. However, there's almost zero cost to manufacture software. So that's
Yeah.
one of the reasons hardware might take a while. And I apologize to any hardware people on this call now. In my experience, the hardware people have often said, "Sure, we can do that. Sure, we can do that. Sure, we can do that." And then I get the hardware and they say, "I couldn't do it." So what I thought was the software needs to be changed to accommodate what the hardware could do. Maybe hardware engineers are better now. Maybe they have more tools at their disposal. But I always find that hardware is limited by physics, right? We cannot change the laws of physics, not at this point. So we might have to accommodate what hardware could not do in the software. And I find that hardware is certainly complex. I'm not going to say it's not complex, but the kinds of things we do in software where we have connections to different pieces of hardware and we connect hardware here and we do something else over there. There's a reason why we often have a 3-tier or 4-tier architecture for software, right? There's a UI, there's the API, there's the app layer, there's the middleware, there's a platform, and underneath the platform is the hardware. Because we can depend on the hardware not changing very often. So it might take the hardware a while to get to a solidified state, but then once it does, we need to depend on it. That I don't know enough about current hardware these days, but my experience is that because hardware is so, we can change a bunch of stuff in manufacturing, but the more we have to change in development of hardware, then the longer that takes. So once hardware starts solidifying, and then often does as they approach final integration for hardware, that's where the software really starts to take off. Did that make any sense? Maybe. So we don't have much manufacturing costs for software, but we do have manufacturing costs for hardware. And that's because the development cycles are different and the kinds of things we do are different in both of them.
Yeah, John, even if looking at the V model in ASPICE, so there is like separate layer for hardware, but there is some integration point, and at least where those hardware and software worlds meet when the integration occurs. So when both prototypes or releases for hardware and software are ready, they then get integrated. And back to your slide with V model, where you say you spend most of your work on the left side. So what's happening in the left side is mostly requirements, architecture, design. So some stuff before we go into the code and integration, right?
Well,
so
it's all that reading, it's all that understanding, it's all that possibly discussing, but definitely understanding either what was there before or understanding what we need to do now.
Yeah, why do you think it's quite hard to manage those left V part, especially with frequent iterations?
So I will say that certainly when I was a software developer, I did not write my code with an eye towards anybody's ability to read it later. right? I thought I added comments. I thought I wrote pretty clear code. I I I think I did because somebody once told me I wrote a third grader could have written my code. I actually said I thought that that was a real compliment as opposed to denigration of my abilities. However, if we don't focus on our ability to read the requirements and the designs and the code, and certainly what was there, then everything on the right side of the V model is so much more difficult. So let's just take an example of requirements written in passive voice. The system shall do almost anything. Well, who is doing that action? That's one of the things I really like about user stories. Now you could use use cases. All right, I don't actually care. But once we understand who is doing the action and the result they want from the action, we now have a totally different take on what the requirements are. That changes everything about the left side of the V model. Does that make sense?
While doing this analysis and our architecture, something, not something, but the kind of work products has to be recorded, because at the end, auditor assessment would check in regulatory industries that, okay, if you had that in place before you were recording, yeah. So that answers the question, but probably it's a tricky question, how to maintain the cadence of being able to record all that before doing the code, or combining these different forms of iterations to achieve both.
Yeah,
So
see,
sorry, I just invite the audience for this discussion, because I'm seeing this kind of challenge in different places, and especially in automotive. Yeah, John.
Yeah. Johanna, if there are not any other questions from the other people, I might ask another one. Yeah, you know, in Agile, we talk a lot about the shifting left of the V model, you know,
yeah.
like that. And what are your considerations that we can get there with a two shift left, more better in hardware? What are your considerations?
So I would really like to see teams collaborate. So instead of people handing off work, I would like the team to work together. Are you aware of the term flow efficiency? I'm going to find my there.
We talk a lot about cross-functional teams where all the
Yep.
capabilities are in one team, you know,
Yep.
hardware, software all together.
Yeah. So in the chat, I put in a link to a series I wrote about flow efficiency thinking. So when a team, regardless of its ability to use literally an agile approach or more iterative and incremental approaches, I don't actually care what lifecycle people use, but the more the team works together, the more you have the software people, the hardware people, the various testers, all on one team to create a product, then the more likely you are to have a really good product. And you need a product person also. So that particular, this is the summary for all of the blog posts I wrote about resource efficiency and flow efficiency. So the V model originally was built on resource efficiency, that the requirements person could create the requirements, hand them off to the architect, who would do the overall architecture, hand them off to design, right? Hand them off to functional spec. And those are different people. Instead, if we have the team working together, that already creates a much better V model if you really need to do a V. And then the shift left business is, how do you integrate the testing along with everything? What would the testers need to know at the time of requirements? What would the testers need to know at the time of analysis architecture? What did the testers need to know, excuse me, at the time of design? And so the more you integrate the testers along with the software and the hardware people, the more likely you are to have a faster product development cycle and a better outcome.
Thank you. Yeah.
You're welcome.
By the way, it's a kind of verification criteria in terms of ASPICE. I would be referencing those ASPICE books from time to time because it's, I've seen a lot of challenges in automotive industries comparing with others like in web development, especially in integration when achieving continuous flow of integration is not so easy. So it's not like website when you can do it a few times a day or an hour. Okay, so I encourage audience to jump into discussion and either through the chat or just turn on your camera and unmute yourself. We have just 5 minutes left. So any more questions?
Johanna, thank you very much. I have to go to another call. I connected with you on LinkedIn, so please accept them.
I will. Thank you, Peter, and thank you for your
Thank you,
great
Peter.
questions.
Thank you. And yeah, just to mention, while this event was organized, so it was part of, as I mentioned, Open Process Initiative. So any knowledge, any practices which were shared by different speakers, so a lot of books now, a lot of articles and webcasts, podcasts, whatever. So I would like to bring those knowledge to work using some techniques or tools. And even from this event, we could distill something which can be used and applied if it will transform in this open process initiative. So we still have a couple of minutes for the questions. Room is open. So.
Yes, I will make my slides available. And Bob, I have a whole bunch of stuff about the risk-based approach to lifecycle choice and manage it. And I also have stuff on my blog. And so yeah, if you want, send me an email also or connect with me so I can send you those links. Oh, nice. Peter, I hope that you do showcase that. That sounds really interesting. Yeah. Yeah.
Mm-hmm.
Yeah.
And yeah, Johanna, your recent books regarding modern management made easy. It is just few words. Are you trying to make life of modern managers made easy, or you have some methods to make it happen? For
so in the Modern Management Made Easy books, I offer many options so managers don't feel so trapped by the way they're supposed to work now. So how can you throw off some of the bureaucracy? How can you make it easier for teams to work together? How can you manage yourself? It's all that stuff. So yeah, I think it's not so much a framework as it is a way of thinking, principle-based thinking. And I find that actually works really, really well. Thank you, Peter. So Jeannie, I think that it's time. I think that we can give people 2 more minutes in their day so that they can go to their next meeting.
Yes.
So
yes. If
thank
any
you all.
Follow-up questions, I think they can still put them in the chat on the event channel, just in case, because I've seen someone join just after the event start. Hopefully they will be recording and maybe they have some questions then. So we maybe just do a few activities offline.
All right, good.
And thank you so much for finding time in these busy schedules.